Just figured out now. So this is a website called Kami. I'm going to be teaching you guys how to use it eventually if we ever go back to school. All right, so what I did is I went through and did all the sheets just to refresh my memory before you so we could talk about some of the issues so I wouldn't have to read it word for word. So I'm hoping if you're watching this, you've at least already read the page, these first 2 pages. If you haven't read these first 2 pages, go ahead and stop me right now and read them and then come back so that I can just highlight the important stuff. I'm doing this right now rather than watch the State-Carolina game because State is getting pounded by Carolina and it's not good at all. Okay, so here we go. Physical and chemical changes. So the biggest important parts that I saw were that for a physical change, things are gonna look different. So I'm just gonna. That did not go as planned. They look different. I'm playing around with the website. And the other thing is that a chemical change will cause a whole new material to form. This doesn't work like I thought it would. Look, let's go orange. Whoa! Okay, yeah, this didn't work as well as I thought it would. And so it's coming on down here. One of the best examples that you'll probably see on your EOG is that when ice, liquid, water, and steam change forms, that's all physical changes. So if we freeze water, all we have to do is apply heat, melt it, and it turns back to water. There's no new substance. Even if we boil a pot of water and it evaporates into the air, even when it turns into steam, if you've ever looked up above your oven, you'll notice the water droplets form up at the top of what they call the hood. That's just the steam turning back into water. So all it does is changes forms constantly. So that's why that's a physical change. The other thing is that usually a physical change, and I know that's not on here, usually a physical change can be reversed, meaning that we can go from liquid to solid, gas, go back and forth. So I think we all know that when we add heat, things melt and boil. So adding or removing heat causes the physical changes. So remember that pot of water that is boiling on the stove. When it starts to boil, all those little particles in there start bouncing around. They get all hyper. It reminds me of some of you in class when you hadn't been outside. So it causes those particles to move faster, and then it causes them to spread apart farther because they're bouncing off of each other, and that makes them take up more space right there. When it takes up space, this is kind of a tough concept. I think this was the hardest part of the whole packet. So when particles spread out, okay, it means that their volume goes up. In return, what that means, and if I could draw a picture, so I'm going to talk about this balloon drawing. Oh, God, that's a great balloon, isn't it? All right, we're going to pretend. So if that's our balloon, and we have particles in there, right? How many have I got? 1, 2, 3, 4, 5. Let's say there's 6 particles in the balloon. And we put it in the refrigerator. And then we take it out and we put it out in the sun. And what it does is it makes that balloon get bigger. Okay, maybe not that much bigger. So because it is closed off, the number of particles inside that balloon did not change. So all that happens when it gets warm are those 6 particles just spread out. So nothing really changes other than the particles space themselves out because they're kind of bouncing everywhere. So the thing to remember about this last paragraph is when it takes up more space, it has more volume. So up here I'm just going to put more volume, and it has less density. Now, the only really way I know how to explain that to you guys is density is particles being packed tight together, okay? So down here you have down here you have it really packed together. That's more dense. Up here they're spread out, so they're less dense. Meanwhile, down here you have a smaller volume, and up here you have a larger volume because it's gotten bigger. And I know that's kind of complicated. But if that helps a little bit. I hope so. It's kind of a hard concept. So down here it says, is the density of steam more or less than the density of water? Explain your answer using the word particles. So to me, what I think of is when you have a pot of boiling water and the bubbles start going and the water escapes up into the atmosphere is what I think of. They spread out once they evaporate. So tonight, ask mama to, or daddy or grandma or grandpa, your dog, your cat, somebody, don't do it by yourself, boil that pot of water and watch the steam come up and it spreads out into the air, just like this balloon does when you take it out and it gets hot. So the way I explained it was the steam particles move farther apart, so the density is less than the water. Because when the water is in the pot, it's like this, okay? Then when it comes up here, it moves apart. So that's why it's less dense here, more dense here. Don't get too concerned if that like super confuses you. So over here we have physical changes of matter. The biggest thing over here to remember is, what else I got? Let's try some underlining over here. If things change color, I don't know, that didn't work well, did it? Let's go back to highlighting. Oh, it's what in the world? It's highlighting like crazy stuff, man. I don't know. Anyway, when things change color, that's also a physical change. So changing shape and breaking are physical changes. So you have a window and it busts into a million pieces. It's just a broken window. You didn't form a new substance. So all of these things are physical changes. So stretching a rubber band, smashing a pumpkin, sitting on a pillow, breaking a window, slicing a carrot, and squashing a rotten tomato. All of those are physical. The most important thing down here is that particles of a material are the same size and shape in a solid, liquid, or gas. It's the movement and space between particles that cause the states to be different. So over here what they're saying is these little blue dots did not change whatsoever in size. They are the same shape, same size. All they've done is move around. So that's what that's getting to. All right, so coming on down to the back page. Let me flip over and find mine. Where are we at? All right, put a check mark beside things. What happens when particles of material move farther apart? So go back up here where I made these notes, and there is your answer. You have a bigger volume and smaller density. So when we look here, we see a new material is formed. That's not true because it's a physical change. Nothing new is formed. The particles become larger. We just talked about how they stay the same size. The particles become more dense. The problem with that is they become less dense. And so the last choice there is the volume of a material comes greater, and that is the correct answer for D. A physical change can do all of these things except, so we have form a new material. So a physical change can't do that because that's a chemical change. So let's look at our other ones. Make something smaller, change a liquid to a gas, change the color of something. So all three of these things are physical changes. So your correct answer there that doesn't fit is forms a new material. What happens to particles of material when heat is added? So we know when we have that pot of water and we add heat to make it boil, the particles move faster. The particles don't go anywhere, they don't become softer, and they don't get closer together. It's the opposite. So the correct answer there is A. So down here, water and ice are made of the same kind of particles. Oh, just a particle because they have an S. Particles in a blank are much farther apart than particles in a liquid. That would be a gas. Oh, I gotta click text again. Okay. When volume gets larger, blank gets smaller. That would be, golly, why didn't my text box just stay? That would be density. Adding blank to a material makes the particles move faster. That's heat. The state a material is in depends on blank and blank of the particles. So this has to do with motion and spacing. Okay, so you didn't use all those words. All right, physical changes of matter, number 3. How is a physical change different than a chemical change? So, a physical change, you might have to write kind of small, changes how something looks, and a chemical change creates a whole new, whoops, let's material, sorry. And it's letting me know that I misspelled chemical. That's fascinating. I was going too fast. Y'all know what it's supposed to be though, right? Something. Okay. How does removing heat from a material change the motion of its particles? So now we're going to go backwards. So now if we have a cup of water and we put it in the freezer and it's going to freeze. When we remove that heat, because that's what we're doing when we freeze something, it slows the particles down. So we are going to put it slows the particles down. Perfect. Now, this down here I'm going to count as extra credit. I am going to do probably 10 points of extra credit throughout this packet, only because, you know what, I'm thinking about it. We may do these in class, but if you want to do them at home, you can. This one, you kind of have to have a scale. It's kind of like what we did with the ice in class, where we had the ice cubes and we weighed it and we put them to the side and melted, and we weighed it again. And some of you couldn't reweigh because cups got spilt and that kind of thing, except reversing it. They're weighing a cup of water, putting it in the freezer, freezing it, and then weighing it again. So if you want to do that and you have a scale at home, feel free to do that. This one, you just take an empty soda bottle or a water bottle, put hot water in it, put the cap on, make it empty, put the cap on loosely, run hot water over it, and then quickly screw the cap on real tight and put it in the refrigerator freezer. Wait for 30 minutes and then take a peek at it and see what happened. We'll probably do those next week if we have time. I'm hoping I see you on Tuesday. We'll do that on Tuesday. All right, so moving on, we have physical and chemical changes. Where's my sheet? All right, so here's what I wish I hadn't done. This is supposed to be before you read, if you see that up here. So you're really not supposed to know the answers to these questions before you read. So here's what I'm going to do. I'm going to move over here and go over this, and we're going to come back to this part. If I had kind of thought about it, I would have put it in a different, why does that keep coming up? I would have put it in a different place. I wonder if I can make this. Oh, I have to upgrade to remove the ad. That's not nice. All right, we'll just not worry about it. All right, so these are the differences between physical and chemical changes. Biggest thing here is, and previously we read that we have particles that are called atoms, and they're fastened together. And when you fasten those atoms together, it makes a molecule. So, for example, if we have water is known as H2O, okay? So what happens is you have these two little things of hydrogen. I don't think I can fit an H in there. That's hydrogen, and that's hydrogen. That's what the 2 stands for. And then you have a little thing of oxygen there. Okay, so that's H, 2 H's, and an O. So what you have is these hydrogen atoms form together to make a water molecule. That's what that is. So that's what they're talking about right here. So sometimes when these atoms get rearranged and fastened in a new way, we make different molecules. So if something busts up these hydrogens and these oxygens and they form with something else, it's going to make a different molecule. They get rearranged. And that's a chemical change when you form something new. So the best example is when clouds begin to form in the sky. That is actually not a chemical change. That's a physical change because it's really, cloud is just water from the air condensing together. And you're not creating anything new, you're just creating a cloud. Now, when you burn things like hydrogen gas, that is a chemical change. Anytime you burn something or something explodes, usually that's going to be a chemical change. Atoms and hydrogen and oxygen molecules come apart. That's what I was talking about up here. And then they fasten together in a new way and form water molecules. Another example of a chemical chain is rust forming. I've seen this before on assessments where they talk about rust and people are like, oh, well, you just have a nail and it turns orange and you just said color was a physical change. Well, but that's not true because rust is actually iron oxide, which is a whole new molecule. So rust is a chemical change because they've been rearranged to form new giddy-ups, new molecules. All right, I'm going to go down here and talk about these two, and then we're going to come back up here. So this kind of gives you some tips as when you think things are probably chemical changes. For one, flames. Usually when you see a flame, it's usually a chemical change. Usually a chemical change only goes in one direction. In other words, you can't undo it. If I explode a firework, I cannot take the pieces and put them all back together and make the firework again. You can't do it. If I burn a match, I can't put the pieces back together and make a match. That's what it means by one direction. If I have ice and I melt it, then I can go back the other direction and freeze it again. That's why it's physical. So it says when a candle burns, a chemical change is happening. What could you do to a candle that would cause a physical change? And I thought the easiest one for me was color the candle, because if you change the color of the candle, then that would be a physical change. See if you guys can come up with anything else about the candle. I want to see what you guys come up with. Down here it talks about explosions are often chemical exchanges, like fireworks, exploding balloons, things like that. Fireworks are, but when you blow a balloon up and you put too much air up and it pops, that's a physical change. It's kind of like a broken window. You're just left with a broken balloon. Sometimes there are examples when it's both chemical and physical. So there's some examples that you really have to think about what they are. So let's see down here. I just went over this. Chemical changes usually cause physical changes to happen close by. Good example. You're watching a fire in a fireplace burn. You're watching a chemical change. You can't put the wood back together. But the fire, because it's radiating heat, warms the air. And by the heat warming the air, that part is a physical change. That confuses you, probably so. Before we move on here, I want to go back to this part and let's answer it. So this is saying write a C beside the ones that are physical changes and a P beside the ones that are chemical. So water boiling on a stove, that's physical. We're going to come back to the penny in the grass, but this is actually chemical. Wait a minute, is it? No, I think that's physical because it doesn't say that the copper is rusting or anything. I think it's physical. If you think it's chemical, we can talk about it and we can see who wins the argument. I'm thinking it's just saying that a penny is in the grass and the grass turns it green, which is just color. I might have to think on that one. Fireworks exploding, that is chemical. Frost forming on a pumpkin, that is physical because if you were to add heat around that pumpkin, that frost would just melt. An old jack-o'-lantern beginning to rot, that is physical because it's just a rotten jack-o'-lantern. Or is it? Well, stick me a little question mark out here as I read. When things rot, it does put things into the ground, which is chemical. I have to think about that one. I think it's physical. Circle T if it's true and F if it's false. Where's my paper? Okay. Chemical changes happen in things that are alive. That is false. Okay. Chemical changes happen in things that are not alive too. Physical changes happen only in things that are not alive. That is false because they can happen in things that are alive or not alive. The way atoms are fastened together changes during a chemical change. That is true. Atoms and molecules are both particles. That is true. We just talked about up here with the hydrogen that it just forms together to make a molecule, and that atoms and molecules are particles. If a material changes color, it is proof that a chemical change is happening. That is false because color would mean that it won't let me highlight. That would indicate that it's a physical change, not a chemical change. Will you shut that door, Grayson? I don't want Tanner to wake up.
I have a Reese's
A peanut butter cup?
Mm-hmm.
But that's your last sweet for the day. Okay? Is it cold out there? You're like a little snowman. Okay. You can have a treat. No more after this
But
thing.
I can't reach them.
Ask Daddy to get them for you. Or get the stool. Okay? Shut the door for me. Sorry. A quick snack intermission with my son. All right. So coming back down here, it says put a check mark beside which is the best sign that a chemical change is happening. Bubbles, that's like a pot of boiling water. That's physical. Flames, we just talked about, that's a pretty big sign when you see a flame that it's chemical. Heat is not a chemical change. That's something that causes a chemical and physical change. And sound is not. So your answer there would be A. Yay! Can I do it that way? How many of these changes are chemical changes? Clouds forming, we just talked about, are physical. A tomato rotting is physical. That's what makes me think this up here is physical. I think I'm right. What am I talking about? I'm always right. I'm just kidding. Plants making food, that is definitely chemical. That is taking sunlight and water and creating their own food. That's not just changing form. So the answer here would be just one. B. What kind of change or changes are happening when the water goes over a waterfall? I don't think that's chemical or physical because all it is water going over a waterfall. So I'm thinking that is A. Well, let me do that again. I think that's A. Write a word in each blank to complete the sentence. Flames show that a chemical change is taking place. Hydrogen and oxygen react to form water. That's what we're talking about up above. Chemical changes always change the way blank are stuck together in molecules. That is, whoa now, atoms. Adding heat causes a material to change. If removing heat causes the material to return the way it was, the change was probably a physical change. Because nothing changed if it's returning the way it is. All right. Moving on along. Sorry, I gotta find my page. Number 3, use the words atoms and molecules to explain what happens when a new material is formed during a chemical change. And on my paper, I wrote back to 29. What in the world does that mean? Back to... Oh, go back to page 29. Ha! Took me a minute. So let's go back to page 29. That's what my notes say. So going back up here, where we were talking about that is right up here, when a new material is formed. So sometimes atoms get rearranged and fastened in a new way to form different molecules. So we're going to use that to help us answer this question. Okay, so I said when atoms get rearranged and they join in a new way, that is a chemical change. That's what I wrote. Did I use atoms and molecules? Uh-oh, I didn't use molecules. When atoms are rearranged to... Let me reword this. When atoms are rearranged, they join in a new way to make new... Uh-oh, come back, friend. New molecules. That is a chemical change. We'll take it. Describe a change that you could see that could be either a chemical change or a physical change. So they gave the example of burning wood and how burning the wood is chemical, but how heat, when heat radiates through the air, then that is chemical. So I want you to see if you can come up with something, a situation kind of like that, and think about using fire. I'm going to say one that was also mentioned, a candle burning is a chemical change. And if you put your hand around it, don't touch it, and feel heat, then that is a physical. Because all you're doing is heating air. Change. That's mine. See if you can come up with another one. All right, so for number 5, if you do number 5, I will give you 10 extra points onto your lowest science grade. It's just asking you, it's kind of, actually, you know what? I'm going to go with 20 points because this might take a little while if you actually want to go for it. So in your kitchen, you have to find 3 physical changes that could happen. You know, don't go smashing things. Explain why they are physical changes and not chemical changes. For each change, tell whether the material that changes could be returned to the way it was. So let's see what you come up with. That's a lot to write for 3 things. And then it says list 3 chemical changes that happen. And the explanation is the same. So 20 extra points. You may want to do that on a piece of notebook paper. And if you'll just label it like page 32, number 5, that way I'll know what you got going on. All right, over here. Is this another before you read page? Yep, it is. I'm going to read this first down here, and we're going to come back and do this part up here because I think it's helpful if you read it first. I don't like the way this is. That picture came out great, didn't it? All right, over here. So chemical changes are also called chemical reactions. They're pretty much the same thing. So anytime that oxygen in the air combines with another material, you typically have a chemical change, and that's what we were talking about with the rust. Or how you have a new penny and over time it starts to change. That's because the copper in the penny reacts with water and oxygen and all the things it comes into contact with, and that's also a chemical reaction. That's where I got a little confused up at the top about the penny being in the grass. But I think the penny being in the grass and being green just has to do with the grass making it green, I think. I don't know. I might go outside and try it. Oh, wait a minute. I can't get to any grass because it's frozen solid. Maybe we shall try it when it melts. Chemical reactions that we see with penny, that's like a slow example because it does not happen overnight. But there is often fast reactions. Burning things, all of those things happen very, very, very quick. So you can have a slow chemical reaction or a fast chemical reaction. One of the ones that we need to survive is when we take in oxygen, a chemical reaction happens that gives us energy. So what it does inside your body, a chemical reaction happens and it turns it into carbon dioxide, what we don't need, and we breathe it out. So there are chemical reactions in every cell of your body. That's how you grow, you get sick, you get better, how you get rid of your poopy doopy, all that stuff is a chemical reaction. Chemical change, same thing. So over here, it is asking you name one way in which oxygen from the air reacts slowly with another material. Name one way in which oxygen reacts quickly and one for explosively. So let's see here. So I said that burning a candle happens fast. I mean, not really fast, but pretty fast. I said that rust forming happens slowly. And a firework exploding, God, I'm struggling here, happens explosively. Those were my examples. You can use your own examples, but that's just what I use. Fix that. Get on my nerves. All right, so coming down here, it's just kind of summarizing everything up. Down at the bottom, if a material can burn, we call that flammable. If a material won't rust or rot, it's called rust resistant or rot resistant. I'm not super worried about those things. So these are just a summary of physical properties and chemical changes. So physical properties is just how a material looks and acts, but it doesn't form a new material. The change is when something just changes color or changes into a new form, but the atoms don't change. Chemical properties tell how and when a material can change, and chemical changes is when you have a new material that forms. All right, let's slide back up here to this part. True or false? Chemical reaction means the same as chemical change. That, my friends, is... go away. That, my friends, is true. Plants use chemical changes to make food. That is true. Only physical changes happen inside our bodies. That's false. We just talked about how your food turning into energy has got to be chemical. Water combines with hydrogen to make oxygen. I think that is true. It's kind of backwards to me. H2. Let's see. Where does it talk about water and hydrogen? Some materials can react with oxygen very, very fast. Yeah, that one's true. Chemical changes tell how and when a material can change into a new material. That is false because that is properties, not changes. False. Okay. Check mark. Which chemical change happens most slowly? Okay, bread baking is fast, and egg cooking is fast, and a candle is fast. So we're going to say a nail rusting. What gas do we breathe in that helps our bodies get energy from food? When we breathe in, we take in oxygen. Which is a chemical property? Ooh. So remember, a chemical property, if you scroll back down here, tells how and when a material can change. So we're thinking how and when. If it's able to burn, if it dissolves in water, can be stretched, or freezes at 32? Well, stretching wouldn't be it, because that would be physical. Dissolving in water would be physical. Uh-oh, I'm getting sloppy here. Let's see if this eraser over here works. Oh, look at, I didn't mean to erase everything. Able to burn would be chemical. Freezes at 32 would be physical. So our correct answer there is D. That's the only one that's a chemical property. All right, so we've already read through this. We're going to come on down here. We're almost done. Hooray, hooray. I know this is exciting stuff. Circle the names of things that can react quickly with oxygen. Underline the things that react slowly. Be careful, some of the materials do not react at all. Ooh, I like it. Circle the things that are quick to react with oxygen. Okay, well, a glass bottle doesn't react with oxygen, the air, I don't think. I guess if something's in it, it could bust, but I'm going to say no. Dry firewood would be slow to react with oxygen. I don't think it reacts at all. This is hard. Salt water. Oxygen. I don't think it really reacts with oxygen. An iron nail, that would be slow. So you would underline this one. A copper penny, that would be slow. Coal, I remember it mentioning coal. Where did I see coal? It was somewhere weird. Just trying to find where it talked about coal. Here we go. It was a list of things. You'll probably find it before me. Where are you, friend? Oh, it's going to kill me. I can't remember where I saw it, but it was about coal. It was a list of things. Oh, well, I'll find it later. I'm pretty sure it was coal was a quick one because you can burn coal. So I would say circle coal, and gasoline obviously reacts quickly. Circle gasoline. The materials on the left are the materials before. Materials on the right are after the change. Draw an arrow on the left. So this will be fun. Here we go. Carbon dioxide and water. Hydrogen and oxygen. Okay, hydrogen and oxygen are water only. Oxygen and iron is rust. Charcoal and oxygen. Aluminum, that would be this one. Food molecules and oxygen make carbon dioxide. Carbon dioxide and water. Charcoal and oxygen. I think I might have one wrong on my paper. Before and after parts. So this is before. I mean, this is how plants make food. That's why it's leading me to think this food molecule right here. But then that would be charcoal, and oxygen would be water and carbon dioxide, which is strange. But I think that's right. I'm thinking this one goes there, and this one goes there. That's a good looking picture, isn't it? That's tough. I think that's right. If you think I'm wrong, you can definitely answer how you think it is, but I think that's correct. All right, what is the meaning of a chemical change? Going back to text. So we talked about up here. that when we talked about chemical changes is when we create a new material. So scrolling back down to our text box, a chemical change is when a new material is formed. What is the meaning of a chemical property? So again, that was right back up here, that it's how and when a material can change. How and when a new material can change. All right, so extensions and applications. This is something we're actually going to do in class. A lot of you do this for your science fair project, so you don't have to worry about this last page. So that is it for your answers. I will see you when you come back. I am excited about building our airplanes. I went to Lowe's and had a tremendous amount of fun buying materials. Can't wait for you guys to get back. Have fun. Enjoy it. Send me some snow pictures. Later.